No, I did something that was so thought to be impossible by me beforehand, but now not anymore. Not anymore. Anyways, take a look at this. So this is a block in TCP server. What it does is it simulates a little shell for you. Let me start this again because I figured out that I actually didn't record the last time, which was weird. I should have done that. You should probably hit record when you record a video. But that's my bad. Alright, so what do you mean it's not found? Oh, I'm stupid. I'm stupid. Let me run that. So it makes a little server on HTTP on localhost 6767. Then you can ping it. You can give it a message and it pings it back. But if you wanna do a second connection, it just waits. It hangs until you close that connection. Now to make this asynchronous, you have to make a lot of modifications, like adding this keyword, and this just makes the server asynchronous, which is insane. You just do blocking code, and the blocking code becomes asynchronous by itself. Can you believe that? It is that simple. It is. Why does nobody do this? Your dynamic language JavaScript, you can do that. You don't have to use async. This is that. This is it. Is hello. But yeah. Anyways, you can do this to anything ever. So anything that has an async backend to it. Like can be asynchronous as long as you make it asynchronous by default. So fn asked, no, fn served, fn served this port do end, and then you move all of that logic from the top back here. You serve it on the port, and then you print it that you serve it on the port. While true do let con accept spawn serve con, and let me give it a port. Let me give it the port as the counter, and let me actually remove that counter. And let me actually do port -1, so that the first request, the first ping is gonna be, oh, and I actually didn't spawn it, so nothing happened. But let me do spawn serve. So then we do spawn serve at 6767. And let me do two more servers actually. 6768 and 6769. We just spawned on 3 servers. Zero cost, zero mental cost at least. So we ping here, and we ping in the higher one first. Ping, pong 6768, ping 6767. Every client has its own state, as you've seen before. Let me actually RL wrap this as well, so that I have my arrow keys. Ping, 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 ping. Different state. This is all you have to do. This is all you have to do. And the way this is done is this is tightly integrated into the scheduler. So whenever you hit, so first of all, this is all fibers. So if you're familiar with coroutines, it's almost that. It is almost that. So it's less lightweight than fibers. It is more capable than fibers. It is more lightweight than coroutines, but it's less capable than coroutines. You actually do have channels, actually. I don't know why I said that twice, but you do have channels. You can send to them. That is what I'm gonna do when I want like actual safety. But that's not gonna happen today. You do have channels though. Chan const c equals chan. No, let's c equals chan, and then you can do something with it. You can just send to c and then to. That's all you have to do here. Anyways, how this works? This works based on a generic async, like this little system. So the scheduler has as many files as you want, and when you hit this, so this is IO. This like back in the implementation, it sends a wait token in there, and then it tries to put that like on the current fiber. And when it puts it on the current fiber, it yields. Now the thing about yield is when you yield, you will have to go to a different fiber. If there's no different fiber, you just don't do anything. You park the current fiber, you wait until it completes. That's all you can do. That's all you can do. You poll it. You just poll it until it's done, and that's just what it is. So it's not. It doesn't behave exactly like blocking code, and this code is actually non-blocking by default. It just looks blocking. And then when that completes, you get back this whole thing. And what's different about this? Is that they're generic actually. So you have this wait token. So if you go into async backend.zig right here, you have an async job. It has a fiber ID to it. It has a kind. So a kind. So now we just have 3 of them, right? But it's not going to be that hard to extend them. We have a file handle, which obviously I'll have to do more. I'll have to make more generic, but this is super like it is super close to being generic. All right, I'll have to have somebody smart actually do that for me, unfortunately. Message ID, that's internal state, and offset is internal state, and then you have a buffer. So a buffer is just there for receive. Is you know, and max bytes as well. That's just stuff that's is kind of there until I actually finish it, until I make it fully generic. And the async backend has to implement all of that. So you can actually implement IO Uring instead of this. So right now it just runs on poll. If you're familiar with POSIX poll, it uses that. Not epoll because that's specific to Linux, not Uring because that's specific to Linux, not KQ because that's specific to macOS. And I'm the only user here that uses macOS actually. And I do have